In this video, we're going to do the final example from the percentage yield handout, example number 3. Let's take it away. Examine the following equation and complete the following questions. So we have, and this should be an arrow here, so we have some glucose. It's going through a reaction where we get two compounds that are produced, so essentially a decomposition reaction. We have to make sure it's balanced, and from here it looks like it is. And so what we want to do is we want to find the theoretical yield of ethanol available from 10 grams of C6H12O6 according to that reaction. So basically what we're asking you is, if you have this reaction happening, so write out your balance equation, C6H12O6AQ, becoming 2 ethanols and 2 CO2s. What mass of ethanol could you potentially make theoretically? So that's what your theoretical yield is. And so we have 10 grams of glucose, 10.0 grams of glucose, and we want to figure out what the mass, let's call it theoretical, because that's what we're really asking you, is going to be for the ethanol. And it's really just going to be the moles times the molar mass. So we can simply do a mole ratio between our glucose and our ethanol. We don't need to find a limiting reactant because there only is really one reactant here. It's the glucose. We just need to make sure that we have it in moles before we can figure out how many grams we'll have. So theoretically, if nothing went wrong, our stoichiometry is going to tell us how much we can make. So let's just write out our molar masses here and here for these respective compounds. So for glucose, 6 times 12.01 plus 6 times 16 for the oxygen, plus 12 times 1.01 for the hydrogen. And so we get 180.18 grams per mole over here. And then for the ethanol, 2 times 12.01 for the carbon, plus 6 times 1.01 for the hydrogen, because don't forget there's 6 hydrogens there, plus 16 for the oxygen. And so that will give us about 46.08 grams per mole. So let's go ahead and convert this into moles. So the moles is going to be the mass over the molar mass, which is 10.0 grams over 180.18 grams per mole. Cancel those out. So 10 divided by 180.18, and we get approximately 0.055500055 moles. And so now we can do our mole ratio between our reactants and our products. So it's a 1 glucose for every 2 ethanol ratios. And so we can use that mole ratio to find the moles of ethanol produced. Is basically just doing our moles of glucose times 2. So we'll do 0.0555 moles of glucose, C6H12O6, times the ratio, which is 2 moles of ethanol, C5H5OH, over 1 mole, because it's a 1-to-2 ratio, of glucose, C6H12O6. We can cancel out the moles of glucose there, and we're left with moles of ethanol, so times 2. And again, I left all the digits in my calculator, and so we get 0.111000111 moles of the ethanol. Now, it didn't really ask us for theoretical yield in mass, but I'm just kind of looking ahead, and I can see that the questions later are going to ask about percentage yield, and we're provided with masses of what's actually produced. So I'm going to go ahead and just give the final answer as a mass. And generally for theoretical yield, when we're doing something for practical purposes, we usually want to have a mass to have to speak to, because we generally speak in terms of mass when we're making a medication or making a product. We want to see how much mass we came up with. It's just more relatable to us as opposed to just this many moles produced. So let's just do our last step here. We'll convert that into mass. So our mass of the ethanol is going to be the moles times the molar mass. which is the 0.111 moles times a molar mass of 46.08 grams per mole. Cross out the moles, so times 46.08, and we get approximately 5.114885115 grams, which we can do according to our sig figs. So we had 3 sig figs, so we want to do 3 sig figs for our final answer there as well. So approximately 5.11 grams. So we can put a therefore statement, therefore approximately 5.11 grams of ethanol could be produced. So it really could be produced because it's our theoretical yield. So this is our theoretical yield, assuming nothing goes wrong. Now in part A, it says you did this particular experiment. You took 10 grams of sugar and you produced 0.664 grams of ethanol. 0.664 grams of ethanol. And we want to know what the percent yield is. So this 0.644 grams is the actual yield. I'm hoping I didn't make a mistake because it's going to be a pretty low percent yield, but let's take a look. So we're going to have our percent yield is equal to the theoretical yield. Actual yield over the theoretical times 100%. And our actual yield is 0.664 grams. Our theoretical was from the question up there, 5.114885115 grams. Cross out grams times 100%. And we get, so 0.664 divided by that answer times 100. And we get about 12.98171875% to 3 sig figs again. So about 13.0% if you're rounding to 3 sig figs. So you can say that therefore the percent yield is approximately 13.0%. So we might have had poor collection technique. Maybe our reaction didn't happen all the way if we were trying to decompose it. Maybe we had impure reactants. So there were a variety of things that could have led to such a low percent yield. Let's just double check the answer. I'm not sure if that's reasonable for this reaction. So I do want to double check just to see if we're on the right track. And so if we go to our mass and percent, you'll notice there's an answer key where you can check your work. And that's what you do if you're not sure. You go ahead and check your work. So it's the one with the glucose. And let's see. So here's our answer key. Let's go down here to the glucose. And it looks like... yeah, it looks like we got so it was really low, but yeah, that happened. That actually worked out to being about 13% yield. So we're on the right track. That's right. So it was just a really bad experimental design, poor collection, or something that happened. But at least we know we're correct in that case. And it does happen. We have really low percent yield sometimes because you don't know the nature of the reaction. You don't know how it works. You don't know what to take into consideration, and you have to improve your design. So if you're consistently getting something that low, it's definitely something to do with your design or the way you're carrying out the lab. Or there could be side reactions, for example. So now let's go ahead and take a look at this next question. If a student gets 95% yield, what is the mass of ethanol that was produced? So what we're basically saying is this. We're saying that the percent yield is the actual yield over the theoretical yield times 100%. Now in this question, what was given was the percent yield, which is 95%. And you could also see that as 0.95 if you divide by 100, just to get the fraction form there, decimal form. Okay. And the actual yield is what we want to find out. So we can rearrange this. We can say that actual yield is equal to the theoretical yield times the percent yield over 100. So the fraction version of it, okay? So that's going to be equal to theoretical yield is what we had from our previous part of the question. We said about 5.114, so on and so forth. So I'll put that in. So 5.114 grams. And I'm going to put all my decimal places in there when I do the calculation and round at the end. I just didn't write them all down. Times the percent yield as a fraction, 0.95. It's kind of like saying if you had a test out of 10 and you got 95%, what did you get out of 10? 9.5. You just do your 0.95 times 10. Here I'm doing 0.95 and my test is out of 5.1148, so on and so forth, grams. And so that's going to give me, so it was, my full decimal places were 5.114885115 times 0.95, and it would be about 4.859140859 grams would be my actual yield, what I actually obtained. But we're going to do it to 3 sig figs, so approximately 4.86 grams. So therefore, the actual yield is approximately 4.86 grams. It means that when the student or the person, whoever did this lab, did the lab, they collected 4.86 grams of ethanol. That's what they actually weighed out, which is a much better percent yield than the 13% that we saw in the previous example. So maybe a better design happened, we improved upon it, and that helped us out in the end. So again, you can check your answers by going to our answer key here, and it said about 4.85, probably different rounding, but the point is that we need to round at the end so you're not too far off. So 4.85% because of the 9, 86% because of the 9 over here, up there. So the next video is example 4. There's a video link for you over here. The answer key is included in that video link, so you can try that out. So pause the video, try it out, and then continue it. See if you're on the right track with your work. So what we saw in this video series was how to was the understanding of the concepts of theoretical, actual, and percent yields. Finding theoretical yield required you to use stoichiometry with your limiting reactant. Actual yield is the one that you actually weigh in the lab, and it's typically given to you in the question. When you're asked to find theoretical yield, it's just doing basic stoichiometry, and you need to use your limiting reactant. So that's the end of theoretical and actual and percent yield. Please make sure you do enough practice problems to understand the concept fully, and understand that in previous worksheets and notes, when we're doing practice problems and we're asking you to find how much could be produced from this mass, you were just doing theoretical yield. We just didn't call it that. As usual, for theoretical yield and percent yield, you can find some practice problems in the learning goals section. So you can see the practice problems over here. First do the ones from the homework and then go ahead and do practice problems in the worksheet until you understand them. Make sure you check your work and answers as well.